We're up to problem 9 on page 2. And again, this is a multiplication. That's what the parentheses are there for. And it's 4 times root 3 times 5 times root 3. It's all multiplication. So again, if I want to, and this is not the only way to do this, but I can reorder the multiplication to make the results a little more obvious, maybe. Now I have 4 times 5 times root 3 times root 3. The 4 times 5 changes to a number 20. Root 3 times root 3 is root 9. And root 9, square root of 9 is 3. And finally, we have 20 times 3, giving us final answer of 60. And as I said earlier, if you type this into your calculator just the way it's printed, it should come out 60. Number 10, we start using a little distributive property here. It's this times that minus this times that. So I'm going to write this times that in the order that makes it less cumbersome. 3 times 5 times square root of 2 times square root of 2. And then minus 3 root 2 times 7. I'm just going to write 3 times 7 times square root of 2. Now simplify each part and we'll see where we are. 3 times 5 makes a 15. Square root 2 times square root 2 makes square root 4. And then 3 times 7 makes 21. And that square root 2 stays as it is. And of course this is really a 2. So we have 15 times 2. Take away 21 times the square root of 2. 15 times 2 I can change to 30. And this is just like if we had 30 minus 21x. We would say, don't go any further. You don't have any like terms to combine. This is the number 30. This is 21 square root 2's. So these are not like terms. Part of the game here is knowing when to stop. So you stop right there. Over to number 11. Now this is what you could call a FOIL problem. First, outside, inside, last. So first we do this times this, and I'm going to speed it up just a little bit. I hope that's okay. I'm going to take the 4 times 7 makes it 28. Let me make that look like an 8. And the root 3 times the root 3 makes a root 9. So that's from doing that times that. Now I do those multiplied together, and it's plus. 4 times 2 makes 8. So it's 8 square root 3. We're done multiplying by 4 root 3. Now I'm multiplying by minus 5. Minus 5 times 7 root 3. The minus 5 times 7 makes a 35. And the square root 3 stays with us. And finally, minus 5 times plus 2. I get a minus 10. Now, can we clean this up at all? Let's see. This is 28 times 3. That's really a 3. And 28 times 3 be 84. And in the middle, we have some like radicals. 8 root 3's minus 35 root 3's. That would be minus 27 root 3's. And there's minus 10 waiting patiently at the end of the expression. And the last thing to do would be put these together. 84 minus 10. I can make this 74 minus 27 square root 3. And once again, we have unlike terms. These cannot be combined. So stop here for number 11. Okay. And the 12 is this strange looking thing. Again, it's a FOIL problem. So I'll start with doing first terms. The 4 can come out in front. And the root w times the root w makes root w squared. We'll come back and fix that later. Now I'm doing this times this. And it's positive times negative makes negative. And we have square root of w times square root of m gives us square root of wm. Use that up. Now we move on to this. Minus times plus makes minus. The 5 times 4 makes a 20. And the root m times the root w, make that root mw. And last multiplication step, minus times minus, make that plus. And the 5 stays out in front. And root m times root m makes a root m squared. Can we do more? Yes. Square root of w squared would just be w. And in the middle here, the wm and mw are the same thing. It's multiplication, so backwards is okay. We have minus 1 of those, minus 20 of those, so we have minus 21 root wm, or root mw, whatever you prefer. And at the end here, we have plus 5. Square root of m squared is m. So this is as far as it goes. No like terms now. 4w minus 21 square root wm plus 5m. Oh, and if anyone's thinking, well, why am I not using absolute value here? Good observation. You know, if w was negative and we squared it and then take the square root, we'd get the positive, opposite value of the negative w. But we're assuming in all of these that the variables are not negative. One more FOIL thing here. Root x times root x makes root x squared. Then root x times plus 3, we get 3 square root x. Done with the root x. Now with minus 5 times root x, I got minus 5 square root x. And then minus 5 times plus 3, I got minus 15. So this square root of x squared is x. We do have like radicals. 3 of these minus 5 of these makes minus 2 of them. And an ordinary integer at the end there, minus 15. That's our finished answer for exercise 13. That's the end of page 2. Next video will be page 3.